A warm welcome to this session of Electrician Trade. Today, we are going to see drawing single line diagram of transmission and distribution system. At the end of this session, you will be able to trace the transmission and distribution system which you have visited. Identify the equipments in sequential stages of transmission and distribution system. Prepare the layout and draw the single line diagram of the transmission and distribution system. Electrician toolkit and equipments required. Hand notes on visited power plant, transmission and distribution system. Drawing sheet, pencil, eraser, scale, personal safety protections. Transmission and distribution system. Before getting into practice, let us have a brief view of AC power supply system. The conveyance of electric power from a power generating station to the consumers is called electrical supply system. The electrical power supply system consists of three main components. They are the power station or generating station, the transmission system and the distribution system. Generating station. The place where electric power produced by the parallel connected three-phase alternators or AC generators is called generating station. Single line diagram of transmission system. Transmission system. The transmission system can be categorized as primary transmission and secondary transmission. High voltage primary transmission. The electric supply, that is 66 kV, 132 kV, 220 kV or greater is transmitted to the load center by three-phase, three-wire overhead transmission system. High voltage secondary transmission. The area far from the city which are connected with receiving station by line is called secondary transmission. Line diagram of distribution system. Distribution system can be categorized as primary distribution and secondary distribution. Primary distribution. At a substation, the level of secondary transmission voltage, that is 66 kV or 132 kV, is reduced to 11 kV by step-down transformers. Three-phase, three-wire systems are used in primary distribution. Secondary distribution. From the primary distribution line, that is 11 kV or 415 volts, electric power is given to the secondary distribution substation. This substation is located nearby consumers area where the level of voltage is reduced by step-down transformers is 450 volts or 240 volts. These transformers are called as secondary distribution transformers. This 415 volts or 240 volts line is called the secondary distribution line. In this line, three-phase, four-wire systems are used. Layout of distribution system. Secondary distribution system can be divided into three parts. Feeders. Those electrical lines which connect substations to distributors are called feeders. Distributors. Those tappings which extract LT power supply from feeder lines to the consumers are called distributors. Service mains. The normal cable which is connected between distributors and consumers load terminal are called service mains. Equipments in sequential stages of transmission system. I hope now you all have understood the basics of AC electric power supply system. Now let us start our practice on drawing single line diagram of transmission and distribution system. For this exercise, we need to visit the nearby transmission and distribution line system and power plant. We have to identify the sequential stages of transmission and distribution line system over there. Trace and identify the various types of equipments like transformers, feeders, circuit breakers, isolators, CT and PT, etc. from the generation to the consumer points in the sequence of transmission and distribution system and note them carefully. Note down their details in Table 1 for the transmission system and Table 2 for the distribution system. Power transformer, capacity 11 kV or 220 or 500 kV. Set up the generation voltage. Circuit breaker, handling capacity 66 to 500 kilovolts. Isolate equipment for maintenance and changing the transformers. Bus bar, metal conductors of copper. These are usually rectangle tubular bare copper bars supported with insulators. Steel tower. These are various shaped iron made of angles. Height of 23 to 30 meters. To set up HT and EHT lines. Primary grid handles capacity of 220 or 66 kilovolts and more. Used at primary transmission lines. Feeder conductor wires. Electric lines which are connected to generation station to substation. Power distribution centers. Isolator depends upon the capacity of the substation. It is a type of switch which is employed only for isolating the circuit when the current has only been interrupted. PT or potential transformer depends upon circuitry. It is an instrument transformer which is used to measure high AC voltages by means of its proportionate lower values. CT or current transformer depends upon current capacity. It is an instrument transformer which is used to measure high AC current by means of its proportionate lower values in its secondary side. Tab change equipment, provided HV side, used to regulate the output voltage manually according to the line voltages. Control panel room depends upon the capacity of the substation. It consists of MCCBs, control equipments, meters, or assembled or mounted in steel panels in the control room. Distribution transformer 33 kilovolts or 11 kilovolts to 415 or 250 volts, which steps down the primary voltage of 33 kilovolts or 11 kilovolts to secondary distribution voltage of 415 or 250 volts. Circuit breaker depends upon the capacity of the substation, which automatically cuts off power supply when senses the fault in the system. Lightning arresters, power 18 into 10 power 5 kilowatt. It is a protective device to protect valuable equipments. It arrests and charges over voltage to earth during lightning strokes. Air breaker switches or isolators depends upon the capacity of the substation. It is used to isolate equipment for maintenance or replacement, and that can be operated manually. Insulators depends upon voltage range. To insulate line conductors or equipment at different voltages with respect to the ground stretcher. Capacitor bank depending upon capacity of substation. To improve power factor. Earthing in general 0 to 6 ohms. It is very important for safety of operating personnel as well as electrical devices. Fencing more than 1.8 meter. Provided at outdoor substation, compound restriction entry of unauthorized persons and live animals. Distribution panel. It is a metallic cabin. It consists of MCCBs, control equipments, meter, and relays are housed in the control room. CTs or current transformer depends upon current capacity. It is a device which is used to measure high current by the transformation of current from a higher value to lower value. PTs or potential transformer depends upon circuitry. it is an instrument transformer which is used to measure high AC voltages by means of its proportionate lower values. Feeder, conductor wires, electric lines which are connected to generation station to substation. Power distribution centers. Distributor depends upon consumer capacity. Distributor lines are low voltage lines from where the tapping of power supply lines are taken for residential and commercial use. Service mains. Cable length depends upon distance between distributors and consumer. Now, cable capacity depends upon power rating. The normal cable which is connected between distributors and consumer load terminal are called service lines or service mains. Note down the earthing system. Note the different values of earth resistance displayed in earth pit. Note down which equipment and installation requires least earth resistance value and irregular value. With the help of above equipment lists and the notes taken in our visit to power plant, transmission and distribution line system, locate the places of equipments in sequence and draw the single line diagram of transmission and distribution system which you have visited. The typical single line diagram of AC power supply system may look like this figure, and the typical single line diagram of the distribution system may look like the diagram shown here. Recap. In this session, we have learned to trace the transmission and distribution system of which you have visited. Identify the equipments in sequential stages of transmission and distribution system. Prepare the layout and draw the single line diagram of the transmission and distribution system. Hope you have understood all the concepts in this session. See you in the next session with a new concept. Thank you.